All right, so let's continue talking about triangles. So let's start with bisectors of triangles. Well, triangles have three sides, so they're going to have three of everything. So when we have three or more lines, rays, or segments, and they intersect, in the same point, they are called concurrent lines, rays, or segments. So three or more intersect in the same spot, they are concurrent. And the point where they intersect, we call the point of concurrency. And in a triangle, the three perpendicular bisectors are concurrent. And we call that point of concurrency the circumcenter. The circumcenter of the triangle, and we remember that perpendicular bisectors bisect a line segment perpendicular to that line segment. So let's see what circumcenters in a triangle do for us. So the circumcenter of a triangle, the place where the three perpendicular bisectors meet, is equidistant from the vertices of a triangle. So if PD, PE, and PF are perpendicular bisectors, then PA equals PB equals PC. So we're going from the side to the angle. So in a real world type situation, if we've got a carnival operator who wants to locate a food stand so that it's the same distance from the carousel, the Ferris wheel, and the bumper cars, we want to find where the best place to put our food stand is. We want it the same distance from the three most popular rides so that people standing in line smell our wonderful elephant ears and say, hey, I've got to go get one of those. So how are we going to do that? Well, we got to find the midpoint between the three rides. So after we find that midpoint, we're going to measure out at the perpendicular to find point E for elephant ear. And that is where the smell is going to get to each and every ride equally and bring us the most money. So we find the midpoints, we find the perpendicular lines, and we remember that perpendicular lines have, we take the reciprocal of the slope of the original line, we take the reciprocal and change the sign. So let's talk more about circumcenters. So circumcenter P is equidistant from the three vertices. So P is the center of a circle that passes through all three vertices, as shown below. And the location of P depends on the type of triangle. The circle with center P is said to be circumscribed about the triangle. Circumscribed means all the vertices of our figure rest on the circle. So over here we have an acute triangle, and our circumcenter is inside the triangle. Next we have a right triangle, and our circumcenter is on the triangle. And the last one we have an obtuse triangle, and it is outside the triangle. So what we do is we put our compass on point P, we set it to the length of one of the vertices, we draw our circle, and we get what we see here. And it moves around depending on the type of triangle that we're dealing with. So let's actually find our circumcenter. So we're going to find the coordinates of the circumcenter of triangle ABC with those vertices. So step one, we're going to graph triangle ABC. Okay, easy enough. A is 0, 3. Puts it right there. B is 0, minus 1. And C is 6, minus 1, which puts it there. So here is our, actually let's get a little easier color to see. Here's our triangle. Then step 2, we're going to find the equations of 2 perpendicular lines. Why are we only finding 2 when we have 3? Well, 2 perpendicular lines are going to meet at the same point where all 3 are going to meet. So we only got to find 2 of them. So we can eliminate a step and still get the same results. All right, well, since we have a right triangle that is very neatly placed on grid lines for us, I'm going to choose to find the midpoint of AB. And 1, 2, 3, 4. There's going to be that midpoint. It is a horizontal line. So my line perpendicular is going to be, it's a vertical line. So my line perpendicular is going to be a badly drawn horizontal line. So the equation of this line is where y equals 1. Then I'm going to find the center of BC. 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. So right here is the perpendicular bisector BC, and it is where x equals 3. Okay, so now I'm going to do step 3, and I'm going to find the point where x equals 3 and y equals 1 intersect. So it's going to be 3, comma 1. And right here is our circumcenter. Now, if it wasn't so neatly laid out for us, we would have to probably use like a system of equations to find out where the 2 points meet. But lucky for us, we didn't have to do that. So we can move on from circumcenters and talk about the incenter. So the circumcenter is named the circumcenter because we're going to circumscribe a circle about the triangle. The incenter is called the incenter because it's pretty much in the center of the triangle. Because just like a triangle has 3 perpendicular bisectors, it also has 3 angle bisectors, probably because it has 3 angles. The angle bisectors of a triangle, well, they're also concurrent. They're going to meet up at one place called the incenter of the triangle. And the incenter always lies inside of the triangle. Unlike the circumcenter, which is going to move around on us. And it's going to look like so. We can clearly see that all the angles have been bisected, so that means we've got an incenter to deal with. And the incenter theorem tells us the incenter of a triangle is equidistant from the sides of a triangle. So that's going to be true if we have ourselves an incenter. And the way we'd write that is if AP, BP, and CP are angle bisectors, then PD equals PE equals PF. So in the circumcenter, we start with perpendicular bisectors. So we start at the side, cut the sides in half, and end up equidistant to the vertices. With the incenter, we start with angle bisectors, go to the incenter, and we're equidistant to the sides. So how might we use that? Well, in the figure we have here, ND is 5x minus 1. NE is 2x plus 11. Here we've got all the angles cut in half, so point N is an incenter. So 5x minus 1 is going to equal 2x plus 11. And then we're just going to algebra this out. And we're going to find out that x equals 4. Well, NF is going to be the same as ND and NE. So all we got to do is take the 4 and plug it in. So ND equals 5 times 4 minus 1, or 19. I like to check, so we're going to do it again. So 2 times 4 plus 11 is 8 plus 11 equals 19. So NF equals 19. Well, we have another question here. Can NG, and let's see, NG's right here. Can it be equal to 18? Well, 18 is smaller than 19. And we know from previous lessons that the shortest distance from a point to a line is on the line perpendicular that goes through that point. So no. NG cannot be less than 19. It is not possible. The shortest distance is NF to line AC. So go ahead, pause the video, solve for ND, and then restart and we'll see how you did. Okay, so we have three angle bisectors, N's an in-center, so NE, NF, and ND are going to be all equidistant, so they're going to equal each other. So let's go ahead, set them equal, and solve. And we're going to go ahead and see that x equals 7. So we're going to just take that x and plug it in. 6 times 7 is 42, plus 1 equals 43. We're going to do NF2 just for fun to double check our work. 4 times 7 is 28, plus 15 equals 43. So ND also has to equal 43. And can NB be equal to 40? No, because just like in the question above, NB is not at the perpendicular. We have a distance at the perpendicular for BC or for AB, that's 43. So NB cannot be 40 units. All right, another one to check your understanding on. So pause the video, solve for QP, start it up, and we'll see how you did. All right, so we got two angle bisectors to point Q. Well, we know from the circumcenter that if we have two perpendicular bisectors meeting the same place, that's where all three are going to meet. Well, same here. If two of them are meeting, because lines that intersect at exactly one point, Q is still an in-center. So QP, QN, and QM are going to all be congruent. So let's just set these guys equal, find our X, plug it in, and see what we get. So 4x equals 6. X is going to equal 3 halves. So we go 3 plus 8. So we get 9 halves plus 8. 9 halves is 4.5. So QP is going to equal 12.5. Yes, we had a fraction, but we're okay with that. Here we're going to go back and revisit our circumcenter and our 3 steps for solving the circumcenter. So we're going to go right back and do exactly what we did before. What was our first step? We're going to graph our triangle. Triangle RST. So we go -2, 5, 1. Then we go -6, 5. There's our S. And then -2, -1 is our T. So we'll plot this guy in here, like so. Then we're going to find the equations of 2 perpendicular bisectors. And we only need 2 because where 2 meet, 3 are going to meet. Plus we have a right triangle on the grid line, so it's super easy. So let's find, so here's going to be the midpoint. The equation of this line is going to be x equals -4. Okay. And then sun is 1, 2. Midpoint's going to be right here because it's 6. So y equals 2. So we have x equals -4, y equals 2. And then we're going to find the point where x equals -4 and y equal 2 intersect. So the circumcenter is -4, 2. Right there on that spot. And once again, if it wasn't so neat, we'd have to find the slope, the negative reciprocal of that slope, find the equation of the line, and then do a system of equations to find where the 2 lines meet. Much simpler process here. We didn't have to do that. All right. Looks like we're at the end. So you have a great day.